Okay, now this is extremely important. We are on Chapter 5, Lesson 2, so 5.2, and now we're on page 206. I want you to follow along, listen carefully. Okay, this chart right here, this divisibility rules chart, this can be of great help to you, okay? This can help you solve problems faster. So you're going to want to remember these rules, and we'll talk about them in just a minute, but you may want to also write them down. And of course, you can always come back to the video to see them, or pause the video, and then you can have the pause screen up while you work on any homework. But this divisibility rules chart is very helpful. Okay, a number is divisible by another number if the quotient, that's just the answer to a division problem, is a counting number and the remainder is 0. Okay, so again, like the last problem, we were looking to see if 32 was divisible by 3. Well, we counted by 3's, but we couldn't get a number where we wouldn't have a remainder, meaning we couldn't land on 32 if we counted by 3's. We'd either land on 30 or 33. Some numbers have a divisibility rule. You can use a divisibility rule to tell whether one number is a factor of another. Okay, so is 6 a factor of 72? Well, let's look. 6 has a divisibility rule. The number is even and divisible by 3. So if the number is even, and this is the number that we're checking to see if 6 is divisible, if it's a factor of it, well, is it even? Yes, it's got 2 in the ones place, so it's even. And the number is divisible by 3. Well, let's look at the rule for 3. The sum of the digits is divisible by 3. So you take any number and add the 2 digits, so in this case 7 and 2. 7 plus 2 is 9. Can 3 go into 9? Yes. So I know that 6 will go into 72 based on this divisibility rule. Okay. Test for the divisibility of 6. Is 72 even? Well, we already said that. Yes. It's got a 2 in the ones place. What is the sum of the digits? Well, 7 plus 2 is 9. Is the sum of the digits divisible by 3, meaning is this number the answer to the sum? The sum is the answer to an addition problem. Is the 9 divisible by 3? Yes. Because if we count by 3's, right, 3, 6, 9, we will land on a 9, so 9 is divisible by 3. So 72 is divisible by 6, what we started with. So 6 is a factor of 72. Okay. Now, let's list all the factors of 72 using some of our rules. So we know 1 and 72 are going to work. So here, and then we list the factors by using a comma. Okay. What about 2? Well, let's look for the rule for 2. If 2 will work if the number is even. Is 72 even? Yeah. So I know 2 is going to work. Now I just have to figure out 2 times what is 72. Well, another way to do this is, it's a fact family. So I can do 2 or 72 divided by 2. Now I look at 2 into 7. It goes 3 times. 3 times 2 is 6. Subtract gives me 1. Bring down. 2 goes into 12 now. 6 times. 6 times 2 is 12. Subtract. No remainder. Again, has to have no remainder, and it doesn't have. So 2 times 36 will give me 72. And if I'm listing the factors, that's going to be 2 and 36. All right, now let's check and see if 3 will work. the sum of the digits is divisible by 3. Well, we already did that here. 72 was 7 plus 2 equals 9. Is 9 divisible by 3? Yeah. So then I know 3 is going to work. Okay. Now again, if you're not sure 3 times what equals 72, that's all right. Just do the work. So I'm going to do this time 72 divided by 3. Three goes into 7 2 times. 2 times 3 is 6. Subtract. Gives you 1. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. Subtract. No remainder. So 3 times 24. Okay, and then I write out the factors 3 and 24. Okay, what about 4? Okay, well, there is no rule. There's no divisibility rule for 4, so let's just do the work. Don't be afraid of the work, guys. Do not be afraid of the work. Do the work. So we're going to count by 4s and see if we land on 72. So 4, another 4 would be 8, another 4 would be 12, another 4 would be 16, another 4 would be 20, another 4 would be 24, another 4 would be 28, another 4 would be 32, and 36, and 40, and 44. We're getting closer. Then 48. 4 more would be 52. 4 more would be 56. Then 60. I'm going to continue up here. 64. 68. 72. So yes, I do land on 72. So there isn't a rule for 4, but if we just count by 4s, and all of you can add 4, you can add 24 plus 4, you can add 68 plus 4. Since you can do that addition, then I know you can solve this problem as long as you are willing to do the work. So this is going to be 4 times, let's see how many 4s we needed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I needed 18 4s to get 72. And if I'm listing those factors, I'm listing 4 and 18. Okay, what about 5? Well, there's a rule for 5. The last digit is 0 or 5. So look at the last number in 72. It's a 2. So that's not a 0 or a 5. So 5's not going to work. Great. I don't have to count by 5s. I know it because of the rule. Okay, 6 we already did. So we know 6 is going to work. That's what we did up here, and there's a rule for that. The number is even and divisible by 3. Well, it is even, and we already know it's divisible by 3 because we did that up here. So we also know 6 is going to work. Now, 6 times what gives me 72? Well, I'm going to do this a little bit of a shortcut because I know my facts a little bit, right? If I do 10 6s, or in other words, 10 times 6, that gets me all the way up to 60, almost coming off the screen here. And then I only need 12 more. From 60 to 72 is only 12 more, so that means I just need 2 more 6s. Because that would be 12. And that would mean I'm up to, that looks like 72, but 60 plus 12 is 72. And I used 10 and then 2 6s, so I used a total of 12 6s. So 6 times 12, and if you know your 12s, then that was even easier for you, right? You were like, Mr. Music, I already know this. And my factors if I'm listing them, are 6 and 12. Okay. What about 7? Will 7 work? Well, if we're not sure, count by 7s. Now, I can jump count. 7 times 10 is 70. And if I had another 7, that would be 77. So nope, 7's not going to work. Okay, what about 8? Well, I can jump count up to 80, right? 10 times 8 is 80. And then if I subtract 8, because this represented 10 eighths here, but if I take 8 away, that would mean I'm back to 9 eighths. And look what I get. And look at, there's a rule for 9 as well, so let's check the rule too. The sum of the digits is divisible by 9. So same thing as the 3. You add the two numbers up. So in the number 72, I just add 7 plus 2, which equals 9. And can you divide 9 divided by 9? Yeah, 9 will go into 9 one time. So that tells me 9 must work. And in this case, I figured out it's 9 times 8. So I'm going to do 8 times 9. And if you know your math facts, that was really easy for you. That's why it's so important to know your math facts. It makes these type of problems that much easier. And if I'm listing my factors, 8 and 9. And now I got them all. So again, this divisibility rules chart can be very helpful. It can help you see numbers quite easily. For example, on your chapter 4 test, you had the number 57 and you had to see if it was divisible. Well, if you know that rule, 5 plus 7, that equals 12. And I know 3 can go into 12, so I know 3 would have went into that 57. 57. Okay, so this divisibility rule can be very helpful so you can see when large numbers are divisible. All right, again, if you have any questions, don't hesitate, raise your hand. Okay, if you have a question, raise your hand. You can always pause and rewatch the video. Focus, can-do attitude. Nothing on here is anything you can't do. Take initiative. That means raise your hand. Use your time wisely. And listen carefully. Thank you. I'll see you on the next one.